Okay, good morning, Prof. Today we will see a mechanism of corrosion of iron, nothing but indirectly rusting of iron, how it is happening. So actually it is the galvanic cell reaction indirectly. So chemical energy will be converted into electrical energy, the phenomena will be going on. Anyway, type of reactions will be going on. If you check iron rod, so on the surface of the iron rod, the formation of rust is not uniform. Did you observe or not? Check it very clearly. Somewhere it will be soft and somewhere it will be rough. Where rough surface will be there, that is calling as a rust. You know very well, because of rust or corrosion on the metal surfaces, the properties will be totally changing. Is it clear or no? So this total phenomena will be going according to electrochemical theory. Yes, you imagine one iron rod surface or iron sheet surface. On this we are getting two regions. We are getting, one is anodic region, another one is cathode region. Yes, you know very well, where anode region will be there definitely what happening? Rust formation is taking place. Generally, you know very well, at anode region, preferentially what happening? Oxidation will be going on. Actually, it is nothing but iron rod or sheet. Yes, what is happening? Oxidation regarding iron. Yes, you take iron is the fresh and it is involving in the oxidation. After that, it is becoming like Fe plus 2 plus 2 electrons. Okay, it is converted like this means is enough. It's involving in the chemical reaction. Involving in the chemical reaction is damage started. This metal characteristics are losing. But at cathode region, what happening? I will explain here. So cathode region, what happening? There reduction will be going on. Which will be undergoing reduction? Iron should not undergoing reduction. Why? Because iron is the metal always having a tendency to lose electrons. Because it is electropositive element. Should not involve in the reduction. But at presence of cathode, whatever available chemicals is there, we are keeping this iron rod in open place. In the open place, what is available? Oxygen gas is there and also moist will be there. Yes, those will be taken by the metal particle, then they are involving in some special reaction is calling as reduction. Okay, whatever anode particles is there, they are also involving in the process. C is nothing but Fe plus 2 particles with oxygen and water. So what we are getting products? Take here 4 moles and here 4 moles. How many moles we are getting? 2 moles of ferric oxide we are getting. Yes. And how many hydrogens is remaining? 8 H plus particles is remaining. Check it, balance now, 4 irons and 6 oxygens, yes, 8 H plus. This is happening at the cathode region, means reduction. Then what happening? This is indirectly nothing but which? Ferric oxide. Still it is not satisfied because it is having some vacant d orbital H. That's why what this iron will do, still it has a capacity to capture the moisture from the atmosphere. Means for example, whatever ferric oxide will be there, still it will absorb which one? Some X number of water molecule. Then we are getting ferric oxide along with moisture. That is only we are calling as hydrated ferric oxide. Hydrated ferric oxide. This only we are calling as rust in case of iron. The metal color will be changing, its hardness will be changing, majority properties will be changing. So once the surface area is rusted, it won't stop. Again that layer will be goes and next it will goes inside till end of the metal. The corrosion process will be going on and it damages entire metal. That's why this is happening. But how we will control the corrosion in case of metals? Yes, this is only big task nowadays in worldwide. Means is nothing but corrosion control in case of different metals. Corrosion control. How do you control the corrosion? So we have different techniques we have. Under this, first we have to learn about the protective coatings. Protective coatings. In the previous class already I told. So if you want to protect the metal, you have to give the coating on its surface with some special metals. Observe one thing here. This whole collision process because of oxidation of that particular metal. Now, by doing something, we have to stop this oxidation of that metal. For that, what we are doing, which is highly oxidized, that metal coating we have to do on the surface of our metal. Automatically, what happening? That coated metal is involving in the rusting, but not our parent metal. Automatically, parent metal will be the safe zone. That's what we are calling as protective coating. By doing protective coating, whatever metal we are using for coating, that will be undergoing oxidation, but our metal or our parent metal should be safe zone. Okay, which type of coating or which type of metals we are using here? Just I will write here, we have different metal coatings we are doing. Metal coatings. Yes, actually, if you take automobiles, majority parts is made up of iron only, a different type of iron anyway. But if you take as it is iron parts, it will be rusted easily. That's why on the iron parts they are giving coating with stainless steel. What is the stainless steel composition? You know, it's like steel color. So we are giving metal coating zinc and tin metals. But sir, why zinc and tin are helpful to control the corrosion? Yes, you take an iron rod you taken and either zinc or tin metal you taken. The electrode potentials of these metals will be less than electrode potential of iron. Automatically what happening? Yes sir, compare with iron, these are having low reduction potential values. Because of low reduction potential values, they are favorable for oxidation or reduction? Oxidation. Automatically here no chance for oxidation. Reduction let it be, but no chance for oxidation. Means they are safe zone. They are as it is like Fe only. So these are relatively having high reduction potential, then no chance for oxidation, no damage of the metal. By giving coating with some special metals like zinc and tin. And I want to give some other inorganic coatings we are doing. Inorganic coatings we are doing or painting we are doing. Otherwise writing inorganic coating only. So inorganic coating means generally they are doing coating with phosphates. Phosphate coating like calcium phosphate, zinc phosphate, like the magnesium phosphate they are coating. By that also we can control the corrosion on the metal surfaces. And another one is nothing but organic coating. Organic coating. So what is the organic coating? Indirectly nothing but paints. Yes, paints. These all are nothing but dyes. All are nothing but dyes means is nothing but organic compound. Yes, if you take iron rod on that you are doing some painting, automatically we can control the corrosion on the metal surfaces. All of you clear? And we have one more technique for control the corrosion is nothing but addition of corrosion inhibitors. Corrosion inhibitors. It is very difficult actually. For example, we are keeping iron rods in this room. We have to close completely this room, and in this atmosphere we have to use some corrosion control or corrosion inhibitors we should add here. But it is very difficult. Why? Because compulsory it will be a little bit opens will be there. That whatever gas particle we are taking that will be go outside. But still this corrosion process will be going on. This is maintaining will be little bit difficult. But I will tell you one more technique. It is nothing but cathodic conversion. Very important and very helpful thing is nothing but cathodic conversion. So how it is possible? How we can make our required metal as the cathode? Yes, possible. Yes. For example, you have one iron rod will be. Yes, this iron rod will be contact with zinc or magnesium or tin. Yes, you know very well, standard electrode potential of iron will be more than standard electrode potential of these metals. Definitely what happening? Okay, whatever metals, yes, just you contact, no need to coating it, just you contact with this one, automatically what happening? These are more favorable for the oxidation. Where oxidation will be going on, that will be calling as anodic reason. So which is acting as an anode, that will be participating in the corrosion process. If it is anode, means automatically this is acting as a cathodic reason. So cathodic reason means will receive the electron actually, but the metals will not. Why? Because metals is always having a tendency to lose the electron. Not losing, not receiving means they are safe zone. Means they are not involving in any chemical reaction. Means they are maintaining their basic structures. Okay, like that is possible. And no sir, other than this, is there any chance? Yes, by using electrical energy is nothing but batteries. Yes, you taken which one iron rod you taken. That iron rod has to be connected with which one negative terminal of the battery, and you have to take a positive terminal to another connection, whatever it is. Means what metal you want to be maintained perfectly, that metal rod has to be give the connection with the negative terminal, automatically acting as a cathode. There is no chance for oxidation, means no chance for reduction. There is no chance for oxidation, only possibility reduction. That's why no corrosion process. I explain no hydrogen oxygen fuel cell. Explain hydrogen oxygen fuel cell. No? Yes, no. Yes, where hydrogen will be contact with graphite rod, there oxidation. The oxidized electrons are passing through that outer circuit, reaches cathode, graphite rod. Their supply of oxygen will be there. In the middle of the two rods, we are taking a KOH solution. So as the power generation is going on, in the middle compartment, water quantity will be going on increasing. So after some time, it's crossing that limit, coming outside through that outlet. So this is a very useful device. I explained already. This is a very useful device to produce a more current with less pollutants and good economy also and good efficiency also. But problem is there. What I told. Yes, we are consuming oxygen. There is a problem to everyone. That's why we are not encouraging such type of devices. This is the theory classes regarding the whole electrochemistry. In this, they left something. Don't worry about this thing, whether it is there or no. Don't think all these things. Hardly it may take 1 or 2 classes extra. Yes, what I explained, as it is, you follow that one. So now already controversy started. Already CBSE board announced that. So deleted syllabus also we are giving in the NEET and JEE examination. Array, you only told deleted that syllabus. How you will give? The controversy started. That's why don't keep all these things in your mind. Anyway, topic is there. Hardly do it. It may take 1 or 2 hours extra time for you for revision. Just what I teach and you follow everything and without any tension. Yes, keep on going. Are you clear? Yes. Now I will explain some problems for you. See, he want how much electricity is required in Faradays. How many Faradays current is required? For first question, to get the 20 grams of calcium, from calcium chloride. Yes. I told already in the Faraday's first class, second law, one final conclusion I told. Anybody? Yes, 1 Faraday means you are getting the equivalent. Work out. Yes, you are sending 1 Faraday current to which one? Calcium chloride solution. We are getting the equivalent weight of calcium. We are getting. That's the answer. Equivalent weight of calcium is what? Atomic weight by its valency 2. Nothing but 20 grams. That's what he is asking. If you want 20 grams of calcium, you have to send how many Faradays? 1 Faraday. Yes. Next question, you see carefully. You want 40 grams of aluminium from Al2O3 solution, alumina solution. How many Faradays is required? We know very well. By sending 1 Faraday through Al2O3 solution, we are getting equivalent of aluminium. Equivalent weight of aluminium means atomic weight of aluminium. Yes, very good. 13, odd number, double plus 1, 27 by its valency 3. Very good. Nothing but 9 grams of aluminium you are getting by sending 1 Faraday. But he want 40 grams he wants. 40 grams of aluminium he wants. Then you have to send how many Faradays? Yes, do it cross multiplication. 40 by 9. Nothing but 4.4 Faradays. You do one more question. He asked in several times in competitive examination. So, how much electricity is required in coulombs? See the question. How much charge in coulombs is required to reduce 1 mole of water into oxygen? Yes, good question. First question. 1 mole of water has to be reduced to oxygen. How much current in coulombs is required? But we have to take 1 mole water only. Anybody? Yes, write on water decomposition. H2O decomposing like 2H plus oxygen. How many moles? Half mole of oxygen. Is it clear? Yes, anyway it is undergoing oxidation. Under oxidation, how many electron change is coming? How many electron change is coming? Plus 2, na? Plus 2 means what? 2 moles of electron is losing. Yes or no? 2 moles of electron losing means indirectly nothing but 2 Faraday's current is producing or releasing. Yes, convert that one into 2 Faradays. So 1 Faraday is equals to how much amount? 96,500 coulombs. Then 2 Faradays means 2 into 96,500 coulombs is the answer. Did you got my point? Yes, water to H plus 2 electron loosed means 2 moles of electron change. 2 moles of electron, 1 mole Faraday, 96,500, 2 moles 2 into, do 1 mole conversion. These are the competitive bits. Okay, to convert 1 mole of FeO into Fe2O3, fresh iron into rust. How much charge is required for this? Three moles. 1 mole you have to consider. For 1 mole conversion, how much charge is required? You know the concept, don't be hurry. Do that conversion first. 2 FeO plus O2 gives rise to Fe2O3. There are how many moles of oxygen? Half mole of oxygen. Okay, now check it. For every iron, oxidation number is plus 2. For every iron here, oxidation number is plus 3. Okay, 2 moles means how much charge? Plus 4. Here, 2 moles means how much charge? 6 moles. This change for 1 mole of iron or 2 moles of iron? 2 moles of iron. For 2 moles of iron, how much change is coming in its charge? 2 is coming change. But he wants for how many moles? That's it. Yes, for 1 mole of iron oxide, required moles of electron is nothing but 1 Faraday. 1 Faraday means is nothing but 96,500 coulombs. Observe carefully. Without giving 1 mole means answer is 2 Faradays. But he mentioned very clearly 1 mole means how much? Yes. You work out 1 more problem. You have nickel nitrate solution amount. Nickel nitrate solution you have, and he is sending a 5 amperes current is sending for 20 minutes. 20 minutes. And how much nickel will be deposited? Atomic weight of nickel is also given. Atomic weight of nickel is 58.7. What weight of nickel will be undergoing deposition? What's 45? Current I 5 amperes. Time T 20 minutes. Don't do simple mistakes. Carefully observe and do workout. Yes. Okay, nickel nitrate. How it is decomposing amount? Nickel nitrate solution is decomposing like Ni plus 2 plus 2 nitrate ions NO3 minus. It's helpful to us. Okay. I is equals to 5 amperes, but time is equals to 20 minutes. Can you take as it is? No. Should take it in seconds. 20 into 60. 1200 seconds. From this can we get charge? Q is equals to IT. 5 into 12, 6000 coulombs. Or what is the basic statement amount? By sending 1 Faraday through that solution, we are getting the equivalent weight of nickel we are getting. Indirectly 1 Faraday means how much amount? 96,500 coulombs you are sending means you are getting equivalent weight of nickel. Equivalent weight means atomic weight by charge. Atomic weight is 58.7 by charge 2. Yes. Okay. By sending 96,500 coulombs you are getting 58.7 by 2. But we are sending 6,000 coulombs you are sending. Then how much will be depositing? How much will be depositing? Work out. How much? 1.82 grams. Yes. Check it once more. I am giving one more important model I am telling you. Find out the EMF of this cell. EMF of this cell is denoted by E or E cell? E cell. Very good. E cell will be asking. And he given one equation to you. Mg converting into Mg plus 2. Concentration is 0.001 molar salt bridge. And Cu plus 2 into Cu. Cu plus 2 into Cu. Cu plus 2 concentration is 0.001 molar. And he given standard EMF of this cell is also given. Standard EMF of this cell given as 2.71. What is the answer? Lot of meaning is here. Observe carefully. Anybody? This is left side oxidation. This is cathodic reduction. Can you write the whole reaction? Mg converting into Mg plus 2. Here Cu plus 2 is converting into Cu. Is it okay? Yes. Now EMF of this cell is equals to standard EMF of this cell from next minus 0.059 by n into log concentration of products ion by reactant ions is nothing but Mg plus 2 by Cu plus 2 ions. Yes or no? Yes. You do it. EMF of this cell is equals to standard EMF of the cell already mentioned 2.71 minus 0.059 by n. Yes, very good. Into log concentration of the magnesium ions is, I think a little mistake here. You can take it as a 100, 100, 100, 100, take it as. This one we can take it as Cu plus 2, Mg plus 2 taken as 00, 00. This is 4 zeros. 00, then what is coming? Mg plus 2 is how much? 0.001 by Cu plus 2 is how much? 0.001. Then you can do simplification. 2.71 minus 0.059 by 2 into log 10 to the power of minus 3 by 10 to the power of minus 4. Minus 4 comes up plus 4. Can we do it or no? We do simplification of this term. It's becoming 10. Log 10 to the base 10. 1. The whole term is becoming 1. Then do simplification. 2.71 minus 0.02095. That's it. This comes to 2.770 volts. E cell. Can I give similar question? Just see what comes. Fe into Fe plus 2. Fe into Fe plus 2. Its concentration is 0.001 salt bridge. And H plus into H2. H plus 1 molar into H2 gas. And given platinum in a electrode is the solid, that is a representation, let it be. Standard EMF of the cell given as 0.44. Standard EMF of the cell is 0.44. Look carefully. First, write down balance equation to avoid the confusion. Chemical oxidation left side, right side reduction, because anode reaction, cathode reaction, reactant Fe is becoming like Fe plus